that's soluble. I take fluoride ion that's soluble, and I create this insoluble compound. Okay, we'll call it a solid. Okay, or call it insoluble if you want to call it I, but it's solid. Okay, it doesn't. Okay, we'll call it a solid. So it doesn't dissolve appreciably. Again, chemists like doctors, we all have our own opinion. Okay, I believe this is correct. Okay, he writes it this way. You better check with him because he's going to grade your test, not me. Okay, if I was teaching you, I'd teach it this way. But again, we all make mistakes. We all have our own opinions. Nobody's right, nobody's wrong. Okay, I'm not bad mouthing them for sure. Makes sense what we've done. So about 15 minutes or 10 minutes, I should get you started on this next section because that's what he expects me to do. Okay, he's probably going to say, "Why don't you do slow go?" Okay. So the fourth page. Okay, a couple terms here. You've got solute, solvent, solution, and molarity. Okay. So if I'm making a solution of compound, okay, let's make some salt solution. Okay, I got some salt. Okay, a pile of salt here. I got some water here. Okay, I want to make a salt solution. Okay, the solute. Okay, the solute would be the material I dissolve. Okay, the solute would be the material that I dissolve. Okay, and it's usually in a lower percentage than the other material. Okay, to make a saltwater solution, I don't need that much salt. Okay. Throw a little handful of salt in a beaker of water, I can make a saltwater solution. So this is the solute. It's the stuff that dissolves. Okay? And what you put it into, the water in this case, is the solvent. And the solvent is usually in a higher percentage. Okay? So usually if you're looking at a solute and a solvent, the solute, what dissolves, it's put into the solvent. This is a lower percentage, this is a higher percentage. The sum of that is the solution. The sum of that is the solution. So you are probably most familiar with a solid dissolving into a liquid, creating a solution. Okay, my mother-in-law, bless her heart, bless her soul, okay, used to make the sweetest darn tea in the world because she poured like 2 or 3 cups of sugar into that half a gallon of water. Okay? The most sickening thing you ever had. She liked it, but none of us, the rest of us did. Okay? Her solute was that sugar, like 3 cups, and her solvent was the water, like a half a gallon. Okay? All right. Solute, solvent, solution. Now, in chemistry, if we're interested in understanding the amounts of these, we have a couple of different ways to look at concentrations. The one that we start out with is molarity. So it's a measure of concentration. Molarity. Basically, to solve for molarity, it's moles of solute over liters of solution. Moles of solute over liters of solution. If you take Gen Chem 2, okay, the first lecture that you have in Gen Chem 2, we teach you a different concentration called molarity, okay, and molality. Okay, so this is molarity. We teach you molality when you take Gen Chem 2, the first lecture out of the box. Okay, but today we're going to deal with molarity. Now, one piece of information, okay, that sometimes people forget. How do I calculate moles? How do I calculate moles? If I had like 12 grams of this sodium chloride, how would I calculate the number of moles? You take the number of grams and divide it by the molar mass, right? And that's equal to the number of moles, correct? So some people might say, I could write this a different way, and I could put number of grams of solute over molar mass divided by liters of solution. And that might be what I use to calculate the molarity, okay? So, again, a couple of different ways that you might need, okay, to solve for molarity type problems. All right, so let's do a couple of these, okay, to get us going on this. First one says, I got 12.5 grams of sodium, 12.5 grams of sodium chloride. I'm dissolving it in enough water to make 150 milliliters of solution. Okay? So I take 12.5 grams of sodium chloride, I'm dissolving it in enough water to make 150 milliliters of solution. What is the molarity? Capital M, molarity. Okay? So because I don't have moles given to me, I have to use my modified equation to do this problem. So I'm going to write it down. Molarity is equal to number of grams divided by, I'll call it MW, molecular weight, just to speed the process up so I don't have to write molar mass because I'm lazy. Okay? Divided by liters of solution. Everybody understand my equation? I'm a big person, okay, both physically and otherwise. I'm a big person of writing equations down and then substituting in. So I write my equation and then I substitute. And I should have enough variables so that I'm only solving for one. So now molarity is what I'm solving for. I have 12.5 grams of that material. I have to calculate the molecular weight. Sodium 22.90, I'm going to call it 23.0, okay? And chlorine 35.45. So 5, 4, 8, 58.45. Everybody good with that? And so 58.45 grams per mole. And then how many liters of solution do I have? 150 milliliters is equivalent to 0.150 liters. The last thing I'll ask before you answer is how many, based on what the problem is given, how Dr. Burns writes the problem, how many sig figs in the answer? You look at the way the problem's written, 3. Okay? So we're going to make sure that our molarity has 3 sig figs. Please punch them calculators and give me an answer.
1.43.
Okay, and he gives you 1.43, and I think that's what we solve. 1.43 molar solution. Make sense? So let's do a couple of these other ones, okay? Let's do number 18 there. Got 20.0 grams of FeCl3, that's iron 3 chloride, dissolved in enough water to make 2.25 liters of solution. Determine the molarity. You'll have 3 sig figs. Go ahead and crank that out real quick before time elapses here so I can tell them where we got to. We'll try to do 18 and 19 and then we'll call it a day. Okay? Then I get to go back to work. Fun. So if you look at number 18, okay, you got 20.0 grams of FeCl3, Did anybody calculate what the mass was?
162.206.
162.206 grams per mole. Okay, I'm using this formula, so I'm just substituting in. And then, how many liters of solution do we have? 2.25, right? So, grams divided by grams per mole, it gives me moles on the top. Moles per liter is molarity, which is supposed to be. Okay? And then my numerical answer should hopefully be what Dr. Burns has got there, 0.0548. Molarity is equal to 0.0548. And that does have 3 sig figs. The first 0 doesn't count. Good? Any questions? All right, let's do 19 and then we'll stop right there. This one's a tad different. Makes you use that equation a little differently. It says, what mass of ammonia, NH3, is present in 275 milliliters of a 15 molar solution of aqueous ammonia? Okay? I'm going to use my same equation here. Okay? Molarity is equal to number of grams divided by molecular weight divided by liters of solution. I use my same equation I've been using, okay? And I should be able to now substitute in based on the data that the problem gave me, okay? Chemistry problems like them word problems in elementary school. Where does all the data go? If you can figure out where all the data goes, you usually can solve the problem, okay? So read it. What mass of ammonia? We're trying to solve for the number of grams here. That's what we're solving for. What mass of ammonia is present in 275 milliliters? Well, I can calculate the molecular weight of ammonia, okay, because you know it's NH3, 14 for the ammonia, 1 for the hydrogen times 3. We'll just call it 17. That rounds pretty good. Okay, it might be 17.01, but you probably get away with 17 pretty well. So I can say that that's 17 grams per mole. How much volume do I have? 275 milliliters. How many liters is that? 0.275 liters. What's the molarity given in the problem? It says 15 molar. It's pretty concentrated stuff. Okay? So there's all of my data. Now all I'm doing is solving for the number of grams. If I do my mathematical operations in the correct way, you should come out with 70 as the answer. 70 grams with 2 significant figures. Anybody not come out with 70 by doing it that way? Anybody not come out with 70? Okay, so hope you learned something. Hope it was pretty clear. Okay?
Thank you.
You're welcome. Have a great day.